Hello, good morning. My name is Alon Nativ. I work at Tomorrowio, and I'm going to talk today about SLO Driven Development. Before I begin, who heard about the term SLA? Raise your hand. Okay, most of you. SLO? Less hands. SLI? Okay, few. SLO Driven Development? No one. Okay, not surprising, actually. When I searched for the term SLO-driven development, I got few results, actually two, and they were both in Japanese. So it's okay that no one knows this term, and don't worry, this talk will be in English. So today I'm going to talk about reliability. Everyone wants a system that is high and reliable 100% of the time, but no one can really achieve it. Do we really need it? Are we aiming for the right target? Today, I'll try to provide you the tool that improve your time to value, save money, and improve your team happiness. So my name is Alon Nativ. I work at Tomorrowio. My hobby is to rant about Python. So if you want to rant about Python, come catch me later. You can follow me on Twitter and LinkedIn, same. A Nativ. And if you want, you can hear me at the Reversing podcast talking about technology and other stuff. Now, let me tell you a bit about Tomorrowio, and the reason that I want to talk about it is because the story that I'm going to tell you soon is very relevant. So Tomorrowio builds a weather intelligent platform. We provide companies weather insights in order for them to improve their business. We're accurate. We are doing a minute-by-minute forecast globally, all over the world, by the street level. So we can tell you that in 1 hour and 12 minutes, it's going to start rain right here at the university, but only 4 minutes after that at the Sarona market. Yes, we're that accurate. We're using machine learning and big data, handling over billions of events per minute in order to achieve that. But the thing that I'm most proud of is that we provide alerts on weather hazards, lightning, floods, and other weather risks in order to save people's lives. So as you can understand, reliability is very important to us. So let me tell you a story, and it's a story about the system that we built. And it's not a story about heroes. It's not something maybe that you should be proud of. It's actually a story about a failure. And the best way to learn is to learn from mistakes, and even better from mistakes of others. So I want to tell you the story so you can learn from our mistakes. So we wanted to build a lightning alert system. And if you see people go under the chair, they're working at Tomorrowio because they're not proud of that right now. The idea of the system, there are sensors all over the world that when there is a lightning alert, collect the location, if it's cloud to cloud, cloud to ground, and many other parameters on the lightning, and send this to us to the system. We then allow our clients to provide area of interest. It can be airports, stations, cities, other places of interest, and define rules on them that we will notify them when there are lightning alerts. So we have many features in the system, but I don't want to talk about them. I want to talk about one feature specifically, and it's regarding the system reliability. The product required something very simple, notify on every lightning in less than 500 milliseconds. Now, anyone that reads this requirement understands easily what we should do. It's not complicated, it's one-liner, easy to understand. So we started with the idea, how to do it. So we started with the design, and the developer that was responsible of the system, let's call him Bob, just a fake name, did a simple design, a serverless system design, actually. It was based on Cloud Function and pub subs. We're working on Google Cloud, but if you're not familiar, it's the same as Lambda and SQS, same terms. And it was very simple, and we did a POC to the system, and it worked great. So we started with the implementation phase. And we started to work on it, and we felt we are building the right tool. We are building something simple, something reliable, something that if there is a problem in the system, everyone can easily understand what to do there. It's the right tool that would take us to the target. I was sure that we are building something simple, just like a bicycle. But then the project was delayed a bit. A week, another week. I couldn't understand why. It was relatively simple. We did a POC, everything working, so why there is delay? And then I figured out that I was sure that we were building something like bicycle, but we're actually building something a bit different. Something far more complicated. Everything was changed. Nothing was like the original design. It wasn't a serverless system anymore, it was on Kubernetes, with internal queues. Nothing, no pub/sub anymore, and everything changed. Very complicated system that is hard to maintain and took us much more time to develop it. And I couldn't understand why. So I went to the developer and asked him, what happened? That's me and the developer. I'm the good-looking guy here, if you wondered. And I asked him, why? Why did we change the system? And the answer was, it just simply didn't answer the requirements. I didn't understand that at that point, so I continued asking questions. Why did we remove the cloud functions, or Lambda? He said, we had issue with the cold start. On some rare cases, we had issues that, because of the cold start, we couldn't match the 500 milliseconds that we need to deliver the notification. Okay, and why did we remove the pub/sub? The SLA didn't match our requirement. But everything worked in the POC. At that point, I told them something like, never mind, I won't repeat it, and that's it at that point. So we went back and looked at the requirement, and what I thought is very simple and everyone understand. Actually, me and the developer saw something a bit different. When he looked at the word every, he said, every is 100%. Now, we all know this sentence that the most important feature of any system is its reliability. So if reliability is so important, we should aim for high reliability. But what should we aim for? 90%? 99%? 3 nines, 4 nines, 100%? Should we create for each system that we build that it will be multi-region, even multi-cloud or triple cloud or whatever, just that it will be reliable 100% of the time? Now, if you will ask Benjamin Traynor, he will say 100% is the wrong reliability target for basically everything. Now, Benjamin, he works at Google, and he's responsible of Google 24/7, which means he's the owner of the SRE team. He founded this term, SRE team. So if anyone knows something about reliability, it's this guy. And he tells us, don't aim for 100%. 100% is the wrong number. And I can tell you that 0% is also the wrong number, by the way. Now, we understand that we don't need to aim for 100%, so what should we aim for? Well, it should be high, because it's the most important feature. We do need to understand that every number that we pick has direct impact on our cost, velocity, and architecture. So the higher the reliability target that we put, the harder it will take us to develop the system, maintain it, and it will cost more. So how can we find what is the right target for our system? Luckily, there are a few tools that can help us do that. And let's go and look what we can use in order to understand what should be our reliability target. So the first thing I want to talk about is SLA. An SLA is service level agreement. And what you need to know about that is that it's a binding agreement. It's a binding agreement with your external users. If you break it, you're gonna pay. And I'm not sure what your company does, but I'm pretty sure that it's not paying your own clients for using your own services. So you shouldn't break the SLA. And the last thing that you need to know about SLA is that it's defined by sales and customers. Now, let's look at an example. What if I told you that I have an amazing cloud provider? A cloud provider that has lots of features, it's relatively cheap, really great cloud provider, easy to use. The only problem is that I can shut it down for over 1 day every month. Shut it down. And if I do that, I'll give you a partial refund. That's my SLA. Will you consider using such a cloud? Will you even check if it's okay with your system? You probably think you won't, but actually this is the SLA of AWS. If you will look at the SLA of AWS, you will see that it can be down for over 1 day and 12 hours each month, and you'll get a partial refund. They can actually shut down their servers right now, turn them back on tomorrow at midnight, and you will get a partial refund. Think about it. And we're still using it. And they can do it every month. Okay? So we understand the SLA is not the target that we really want to push for. Actually, SLA is the bare minimum that we need in order to close the deal. I can even tell you that if you are proud of your SLA, you are probably doing something wrong. Don't try to be hero with your SLA. Try to make it the bare minimum in order to close the deal. Now, the next thing I want to talk about that can help us understand the reliability is SLO. SLO is service level objective. And what we need to know about that is that it measures user happiness. It's easy to remember. There's an O in the SLO, put a smiley there, easy to remember. It measures user happiness. It's your real expectation from the service. We don't expect that Amazon, AWS, will be shut down for hours or even half an hour each month. It's our real expectation, our real expectations and our clients' real expectation. And the people who defined the SLO are product managers with SRE. Now, when I say SRE, it's really dependent on the company. It can be SRE, it can be DevOps, it can be developer. It's dependent on your company. Now, let's try to look what is a good SLO. So we understand that it's much better than our SLA. And we know that we need to, that the SLO need to check if our user happy. Okay, to measure user happiness. So it should be the point that our user are happy before they are unhappy, and for sure before they are mad. So if we have one user, we may be able to ask him, is it okay to send a response after 500 milliseconds, after 3 seconds? We can ask him and we can understand. But usually, we have many users. And then some users might be happy with 700 milliseconds, some with 300 milliseconds. So what should we aim for? For 50% of happy user, 90%, 100%? There is no easy answer for that. But that's why the product manager defines the SLO. The product manager is the user representative in your company. He should know your users. This is his job. So he should help us define the SLO. But sometimes, on many cases, you create services that has internal users. You create something that the users are the people that sit next to you in the company. The developer that sits next to you uses the service. Then you can ask him, what is the cost of failure? What happened if my service returns a response after 3 seconds? What will happen? He might tell you that he can't handle it and all are loose. But maybe, if you will talk with them, you can find out that if they change the algorithm or add caches or change something in the database, they can handle it, and then you can relax your SLO a bit and make your life much easier. So talk with your peers about that. Now, the last thing with this family that I want to talk about is SLI. Each SLO has a few SLIs. And the SLI is service level indicator. This is a key metrics that checks if we meet the SLO. It should tell us if the SLO is okay or not okay. And we should have alerts on it. Without alerts and monitor, it doesn't worth much. And the last thing about that, this one is defined by the developers and SRE, and again, SRE depends on your company. Now, the way we calculate SLI is relatively simple. It's good event divided by valid event multiplied by 100. So if we have a website that needs to return a response in 500 milliseconds, for example, so each response that is under 500 milliseconds with a status of 200 is a valid event. Each response that is taking longer, it's bad event. So it's relatively easy to understand, but there are some cases it's a bit harder. If we look at 404, for example, you can say it's not a valid event. It may be true, but if all of your users get 404, you might have a problem in your system. So we need to be careful with that. Now let's look at a few recipes, how we can define the good SLIs. What is a good SLI? So good SLI, we need to understand we shouldn't have lots of SLIs. We should have about 2 to 4 SLIs per SLOs. Not too much. Don't aim for 10, 20, whatever you think. 2 to 4. And it shouldn't check internal metrics. Not CPU, not memory, not disk, not anything that you think like that. Only things that the user cares about. So let's look at an example. Let's like Google search. Everyone here used it, I'm sure. Now, we as a user, when we're searching in Google, what we want to know? What makes us a happy user when we use the service? So we want it fast. Let's say 200 millisecond response time. So that can be one SLI. We want to get a number of results. We don't want to get empty page or one result. There is probably a problem with the search. We also want that it will be on top. The answer that we are looking for should be in the top clicks. It shouldn't be in the page, in the second page or the 10th page. I don't know when is the last time that I moved from the first page in Google to another page. Okay, so this is what interests us as a user when we're searching in Google. So think about that. But what we don't care about is the CPU. I never heard anyone search in Google, find the right result, and say, damn, the CPU was too high. Who cares? We as a user don't care about the internal metrics. So think about your user, what the user cares about. Sometimes we need to add metrics on the user side, close the loop to understand what the user really feels. Now, an SLI should also have high correlation with user happiness. So if we look at this graph, we have happy users, unhappy users, and happy users. So the SLI should be red when the user are not happy, and green when they are happy. So if we look at the good graph here, it has high correlation to the user happiness. It can be, for example, milliseconds. The response time that we return the website or the service answering. So it has high correlation with the user happiness, and the other one might be CPU or something else, and it doesn't have high correlation, so it's not a good metric. Sometimes we need to add more metrics, generate new one, or add monitors at the client side to get this full picture, and we might need help from the support team or other team that might help us. Now, the next thing I want to talk about is, okay, let's talk about errors. Errors can happen to anyone. It can be planned or unplanned. We already understand that we are not aiming for 100% reliability, so eventually we will have errors. Now, how do we measure these errors? How do we count them? So we use the term error budget. And this is the amount of errors that we can use in our website or service. And it's an easy formula. It's 1 minus our SLO equals the error budget. So if we have an SLO of 99%, our error budget will be 1%. That's easy. Now, we have a budget. Let's spend it. Okay, we need to understand that we can spend only what we have. Think about your company. Your company has a limited money in the bank. It has a limited budget. It can't pay all of the developers and all the DevOps in the company $1 million each month and put hundreds of millions on marketing. They will run out of budget. The person who is responsible of the budget in the company is the CFO. We, as developers, DevOps, when writing services, we don't have a CFO. We are the CFOs. Each one of you is the CFO of your service. So first of all, congratulations. After this talk, go and update your LinkedIn, write that you are CFO of your services. It will be fun to see what the recruiter will start to write to you. Now that you are the CFO, let's understand how we are using budgets. What are the patterns that we are using budget? So one pattern that most people think about it's we have a service, and there is a bug in the slide here in the conversion. But we have a service, and there is an SLI of it, which is green, red, green, and our budget is flat. When we use the budget, when we have an outage, we use the budget, and then it's flat again. So that's one common pattern. The other one is a bit different. Our site is service always running. We have a threshold of a low error rate, and then we're using a budget slowly and slowly and slowly it's declining. Now let's look at a real-world example. This is a graph from Uber. This is how the errors of Uber looks over the week. Now, as we can see, during the weekend, they don't have lots of error. And the reason for that is that they are not doing any changes in production, or barely doing changes in production. So we understand that there is high correlation between the number of changes that we are doing in production to the number of errors that we have. Now, don't get me wrong. It's the number of changes, not the number of deployments. So don't try to do one big, huge deployment once a month. It's the number of changes. Keep your deployment small. Another company that I want to talk about is a company that recently changed the name. Everyone knows about it. Of course, I'm talking about Metagod. And Metagod doing a metaverse for goats or whatever they're doing. Doesn't really matter. This company has two teams, Team A and Team B, let's call them, and a VP R&D, and let's call him Mark. And he saw that every month they're using too much budget. They are spending more budget than they have, the error budget. They're using too much error budget. So he told his team, fix it. Let's make sure we are defined SLO and we can meet in our targets. So each team went to an offsite and thought about a solution. Team A decided we need more quality, we need more tests. Let's write more tests. Team B decided our CI/CD is very slow. Let's improve it. Let's make it faster. Now, what is the better approach to improve reliability? Team A, Team B? So you probably have an opinion about that, but without data, you're another person with an opinion. So let's add a bit data to the story. And in order to add data, I want to talk about two terms fast, MTTR and MTTF. And MTTR is mean time to recovery. It's mean when we have a downtime outage, it's from the start of the outage till it ends. Easy to understand. MTTF, mean time to failure, it's the number that our site is up. Okay, so this is the two metrics that we will look at. Now, when Team A worked on test, they actually improved the MTTF. Because right now they have less outages, less bugs, so they improve it. Team B improved the MTTR, because now they can do rollback much faster, because they worked on the CI/CD. Now, if we zoom out, we can look that at Team A will have the same number of errors over a longer time, because they improve the quality, reduce the bugs. Team B will have the same number of outages they have, but each one will be much shorter. Now, if we compare them, we can see that in order to know which team did a better job, we need to count the red parts. We need to sum the red parts and see what is lower. For example, if we had 4 outages each month and each one was of 1 hour, so Team A now and improve it by 50% with tests, so now they have 2 hours of downtime. But if, for example, our rollback took us 1 hour to do a rollback, and now we can do it in 15 minutes, so now Team B improve it by 75%, and they will have only 1 hour of downtime each month. So it depends, and we need to measure it. And it's important because if you can't measure it, you can't improve it. So in order to improve our quality or problem, we need to measure it first. Now, there are other ways to improve quality. For example, we can change a bit our SLI alerts. Maybe if we will know about an outage 10 minutes before, we can reduce the failure time by 10 minutes. Another option, for example, is to work on gradual rollout. If we can do a rollout to only 10% of our users, so even if we will have an outage of 1 hour, it will be count only as 6 minutes. So there are many ways to improve quality, not necessarily tests. Measure it. Now let's talk a bit about trade-offs. Sometimes you have a database migration or a database update or a security issue that you need to do to a database, and it requires downtime. Now, one of the developers or DevOps can tell you, hey, I can work on it for 2 days and make sure that we won't have a downtime. Great. But what if he needs 2 weeks, 1 month, 4 months? Does it worth it? Maybe it's better to put the service on a maintenance mode for 10 minutes and use the budget somewhere else. So when we have budget, we can use it. What we can do when we have spare budget? First of all, we can deploy new features. Like we saw in the graph of Uber, when we're changing production, there is a higher chance that we will have error. So deploy new feature is a good use of budget. Do a risky experiment. Use pod instances or preemptables. So sometimes they will fail, but you have the budget for it. Scale down your servers. So maybe on the high peaks, you will have a higher error rate, but if you have the budget for that, maybe you can save lots of money by scaling down your system a bit. And use A/B testing that you think that one of them might be risky or fail. Now, we talked about what to do when you have a budget, and that's fun. But when you are out of budget, it's a bit less fun and problematic. So one thing you need to do, or you should do actually, it's a deployment freeze. If you don't have budget, you can't really change production, because each change in production is a risk for an outage. You can prioritize post-mortem bugs or issues. We all know that everyone loves to do post-mortem, and there are many issues there. Some of them we fix immediately, and some of them goes to the backlog, and no one looks at them. So if you don't have budget, it's a good time to look at this list and start prioritizing it in Git. The third thing that you can do is improve your CI/CD, like the example that we saw before. Improve your developer life. You're out of budget this month, work on something else. Work on monitoring, improve your monitoring. Maybe you can know about your bugs faster and reduce your budget usage. If each month your server can't match its SLO that you defined, you might need to reduce your SLO. You might put a target that you can't handle. Each month if you can't handle it, so you might want to relax it a bit. And the last thing is people don't like to talk about, but you might want to deprecate the service. If it's a legacy service, so prioritize it faster. But sometimes even if not, it doesn't worth the business value. Maybe. You need to check it. So when we have high SLOs, we have less budget. It takes us more time at the development process. And we have less sleeping hours for our team. But the most important thing that I want to talk about is the maintenance cost. Google did a research, and they found out that the amount of maintenance they are putting on each service is about between 2x to 10x the amount of time it took them to develop the service. Think about it. 1 month of development equal between 2 to 10 months of maintenance. Now, they found a high correlation to the SLO. The higher the SLO, the higher the maintenance rate. So sometimes you say, okay, I will work a bit harder in the development time, we'll invest 1 more month, and we can achieve higher reliability, higher SLO. You might pay another half a year for that 1 month that you just invested. So think about it. SLO is just not the development time. It takes us all the way to the maintenance. So what we need to do in order to start? So I talked about SLA, SLO, SLI, error budget, trade-offs, how to use them, that we need to measure it. So first we need to define our SLO. We need to use our product usually and define our SLO. This is our start. Then we need to start collecting data, measure our error rate. And then we can start using our error budget. So let me try to summarize the important thing that I talked about. The first thing we need to remember, this approach is a user-centric approach. Think about your users. It's not you, it's your users, what your user wants. Put your users in the center. The second thing, data, data, and data. In God we trust, all others bring data. Use data. Without data, it's hard to make smart decisions. The third thing is use your budget. If you won't use your budget, you're basically losing money or working for nothing. You define the budget, use it. Don't leave money on the table. Use your budget. It will, next month, you won't find this money again. So if you need to take a note and write 3 things from what I talked about, so it should be users, data, and budget. Now, before I'll go, I want to tell you one last thing. Remember that we are software engineers. We are not building bridges. It's okay to have mistakes, and our system won't be reliable 100% of the time. Sometimes it will break. But if you can't measure your reliability manages you. Thank you very much. I was Alon.